Hello everyone. In this video, we are going to talk about Docker, one of the most powerful tool in modern software development. So what exactly is Docker? Docker is a containerization platform that revolutionizes how we build, package and run applications. Think of it as a way to wrap up your application into a lightweight portable container. The beauty of the container is that they include everything your app needs. Your code, deployments, libraries, all bundled together. Your application runs consistently across different environments, whether it is your laptop, testing server, or production. Now let's deep dive what actually is a container. This diagram shows Docker container architecture. Let me walk you through each layer. In the bottom, we have infrastructure. This could be your physical server, cloud instance, or even your laptop. On the top, we have host operating system. This is the operating system running in your infrastructure. This could be either Linux, Windows, or Mac OS. Then we have Docker engine. This is the core component that manages and run your containers. Think of it as a container orchestrating everything. And here is where it is getting interesting. You can run multiple containers simultaneously. Each container is isolated and each container contains its own application, binaries and its libraries. Container 1 runs application A, container 2 runs application B, and container 3 runs application C. All containers are running independently on the same host, but completely isolated from each other. Now let's talk about what is a Docker image. The Docker image is essentially a blueprint or a template used to create a container. Think of it like a recipe or a snapshot that contains everything needed to run your application. It all starts with a Docker file. This is a simple text file where you write your instructions, what base the operating system to use, dependencies to install, what code to copy, and how to run your application. When you run the docker build command, Docker reads the Docker file and creates a Docker image. This image is made up of multiple layers. Each instruction in your Docker file creates a new layer. These layers are stacked on top of each other. This makes the image efficient and reusable. Finally, when you run docker run command, Docker creates the container. A container is the running instance of your image. Here is the easy way to remember this. Docker file has your recipes. Docker image is the prepared meal kit with all ingredients. Docker container is actual cooked meal you are eating. One image can create multiple containers, just like one recipe can make multiple meals. I hope you got an introduction of Docker. Now let's get into the practical implementation. Let's see the Docker in action with a real world example. Here is my Docker desktop. Currently, I don't have any containers running. Let me go to Visual Studio Code. Here is my project structure. I have a folder Docker. Inside the Docker directory, we have 4 files. The first file is app.py. This is our Flask application. Next, we have Docker file. This file has instructions to build your Docker image. Next, we have Docker compose.yaml. This is for orchestrating our container. Next, we have requirements.txt. This file has the dependency details. First, let's go to app.py, our Flask application. In the first line, we have imported the Flask and we are creating a Flask application. Then we are defining a route for home page and we are returning a message, hello from Docker container. We run the app on all instance on port 5000. This is our application. Now let's see what we have in the Docker file. The first line is from Python 3. This is our base image. We are starting with official Python 3 image from Docker Hub. Let me show you what Docker Hub is. Let me go to my browser and type hub.docker.com. Docker Hub is like a GitHub but for Docker images. It is a cloud-based repository where you can find, share or manage Docker container images. Here we see the Python image. We are downloading the official Python image from the Docker Hub. Next, we are setting up a working directory inside the container. Our working directory is app. Then we are copying everything from the current directory and pasting it into the container. Notice you have two dots. One is the current directory. Next is the app directory which is in the container. Next, we are installing all the dependencies that we have in the requirements.txt. Let me show the requirements.txt. We have a Flask dependency. Let me go back to the Docker files. We are installing all the dependencies. In our case, the dependency is Flask. Next, we are making sure the container listens to the port 5000. Next, we have the command section. This command runs when the container starts. In our case, we are executing the app.py. Next, we have docker compose.yaml. Docker compose.yaml file is a configuration file that lets you define and run multiple containers. In the services, we have defined web. This will be our Flask application container. Next, we have build colon and a dot. This tells Docker Compose to build an image using the Docker file in the current directory. Dot represents the current directory. Next, we are mapping the ports. The first one is the host port and the container port. Port 5000 in our host machine is mapped to port 5000 in the container. This is how we access the application from our browser. I hope you understood all the four files. Now let's run the Docker Compose file. I'm going to type Docker Compose up. We see here that the container is created. Let me go to the Docker desktop and make sure that the container is created. We see that the container is up and running. Now let me go to the web browser and see if I can access my application. Let me type localhost and port 5000. Let me run it. We see here the application is up and running. I hope you got a fair idea of the introduction of Docker and its practical use case. And I'm sure that you learned something new today. If you do like this video, please consider to subscribe and I'll see you in yet another interesting video. Thank you.